Welcome to Talking Science Interviews. Matt Miller with you in Studio 4. Today, it's all about this very, very interesting comet that has arrived in our solar system, 2I Borisov. I've got two gentlemen here to talk all about it on the other side of the opener.
On Apple Podcast, Spotify, Google Podcasts, and YouTube for over 550 episodes. This is Talkin' Science.
Rock, let's start with you. You were part of the team that measured the polarization of light scattered by the coma. What does that tell us about its physical characteristics?
Yes, so polarization, I will first of all say, is not a very commonly used technique, but it is a very handy technique because it is in fact scattered light from comet coma. In this case, it can be the surface of the ocean, it can be a ski slope. Will scatter light, and that light will get polarized. And from the way it gets scattered, we can try and learn more about both the composition and structure of particles. And what we found in our analysis of sort of optical, so visual part of the spectrum of comet 2I Borisov, is the particles that are causing this polarization seem to be quite compact and exhibit surprisingly high polarization.
Now, studying the polarization indicates that it's similar to comets in our solar system, like Hale-Bopp, but there is a very special difference and very key as well, isn't there?
Yes, correct. So our results show it's relatively similar to Hale-Bopp, as you say, but Hale-Bopp itself is quite a unique comet in our solar system. We expect it to be really pristine. We think it might have gone past the sun, close to the sun, once before the 90s flyby, but not before that. And similarly, we therefore expect perhaps 2I Borisov had not visited really close to any stars before it came into our solar system.
Well, following Oumuamua, this is the only other interstellar object to be discovered, which I guess makes it that much more interesting to study.
Indeed, yes. As I'm sure my colleague will agree, it is quite exciting to study these objects. We do hope to find more of them in the coming years as sort of better and better instruments come online, such as the Vera Rubin Observatory, for example. But so far it's only two, and the first one wasn't really behaving like a comet, it's more like an asteroid. But so for comet science, this is quite exciting.
And one thing I was fascinated about in the lead up to our chat today, learning that the two papers that have been released on 2I Borisov don't necessarily agree exactly on what this comet is. Rock, very quickly, what's your sort of take on it?
Well, as I was saying earlier, so our observations sort of focus on the polarized light, which appears to be mainly from small compact particles, which might not be quite the same as what the other team has looked into.
Well, Leno, let's chat with you now. What is your analysis saying of 2I Borisov?
Well, first, you said that the two papers don't agree. Well, actually, the two papers are completely independent. We were not even aware of the other research until they were published. And they use completely different technique. The polarization paper is polarization in the visible, while the other paper is mostly using radio waves in the submillimeter. So they're really looking at completely different aspects. So yeah, there are some details that are different, but I would say that the important point is that both agree that Borisov is a comet, but that is a different comet. It's not like our standard comet that we see every day. And I would say that this is really the key result. And the polarization shows that it's similar to comet Hale-Bopp, which is a very, very pristine comet. So that seems to indicate that Borisov is a very pristine comet that has never been close to a star before. And the ALMA paper indicates that it's a comet with dust that is not like any other dust in any other comet. It's big dust grains, and it's important to note that we don't necessarily look at the same grains with the two techniques. So the fact that the two papers don't get exactly the same result is okay, because they're not looking at the same thing. But the story is that the dust that you see with the radio telescope ALMA is also very pristine, and it has even some additional information, is that as the dust, the composition of the dust changed over time, it seems to indicate that these dust grains formed in different places of the original solar system, not our solar system, but where that body formed. So it's actually quite cool that these two papers that were completely independent, different technique, arrive at the same time at results that complement each other. So, science is fun. Could have been much more embarrassing if one of them said, yeah, it's just a stupid comet like all the others, and the other paper said, no, it's completely different. But it's not the case. We both paper agree that this is a very interesting object. And you were saying, yeah, it's only the second one. I would even say it's only the first extrasolar comet, because the first one, Oumuamua, was completely different from anything we have ever observed before. It was a complete freak. And to be entirely honest, we have not understood it completely because we could observe it only for 1 month. And so we did what we could. It was extremely hard to observe because it was extremely faint. And we did what we could. With this one, Borisov, it was discovered long in advance. It was fairly bright by today's standards. So that means that we could observe it for over 1 year. And the pandemic did not help us because most of the telescopes were shut down during most of the year. So we missed a lot of the observations because the telescopes were not operating. And it's just now in January, February, March that we could reobserve it again as it's moving away from the solar system. So it's more like a farewell because now it's really faint.
Well, and one of the key finds in your research is its composition, made up of compact pebbles, indicating the likely makeup of this comet's home system, or indeed wherever it's come from in the galaxy.
Yeah. Yes. So the dust structure of that comet is not exactly the same as the dust structure in our comets. So that indicates that the conditions were slightly different. It looks like a comet, it behaves like a comet, but there are some subtle differences. And to be honest, when we looked at the Borisov at the beginning, we were afraid, oh my God, it's really just a boring comet. But actually, when you start looking in more details, you start to realize, there are some slight differences. And that's really the best that we could hope for, because it is something that is familiar. So we can understand it. We can understand how it works, but there are some subtle differences, and these differences is where we are going to learn more. So there are now these two papers. We need to read them carefully because, again, we discovered each other's paper a few weeks ago, and see, can we learn? Can we get more information from the other team's paper? And who knows, maybe in 1 year from now, we will publish a paper together to get a complete view of the object. There are more papers coming. So I would say that in the coming months, we will collect all these information. And then there will be a consolidation phase where we try to bring everything together and get a complete picture. But it's really interesting to see that this object, which is the first time that we can observe a comet from a different solar system. It behaves like our comets, but it's different enough that we're going to learn on how another planetary system has been forming. That's exciting.
Rock, what's it like for you as a scientist to publish a paper and discover that someone else, another team, has been studying the same object as you and reached a different conclusion?
Well, as I say, or rather, as my colleague said here, I will quite agree. It's mostly really exciting because, as we said, use different methodology, so we expect to see slightly different conclusions coming out of that. But as we now come together in the coming months, indeed, and try and find common ground, try and find the theories that will fit all of the observations, we'll learn new things, and obviously that's what science is all about, so it's really quite exciting.
It absolutely is. Gentlemen, I really appreciate a little bit of your time this morning for this Talkin' Science interview. Tuai Borisov, a very interesting find indeed. Rock, Enno, thanks very much for your time.
Pleasure.
You're welcome.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favourite podcast app 5 days a week. Just search for Trek Zone and subscribe.